what we're gonna do, we're gonna go a quick review about uh, TCP IP and the OSI layers. Let me share my screen. So this TCP/IP and the OSI layer is not a new thing for us, right? In a networking, for a network guy or for any IT guy, okay? And basically why it is important, okay? Still, every network engineer guy have to go through this models. The one reason behind that one is the structured approach, how we gonna solve the issue, how we gonna solve the problem. You know, there is a reason for everything, right? Why we have to study if we are not solving something, right? So what we are solving it. For an example, if there is a problem with either with the protocol or if it is a problem with a card, NIC card or the cable, there should be some segregation, like at what layer we are thinking about. Whether there is a problem with the session or whether there is a problem with the port number, there should be some segregation. Okay, so the troubleshooting is very important if you are thinking about the layered approach. It will be very easy to go through all those troubleshooting steps. So yes, this OSI layer is having a 7 layer, right? Always we can't say that 7 layer means like any of this layer we're gonna name them anything, right? So we can't say the seventh layer is the physical layer. Physical layer will be always a layer one, and the seventh layer will be always a what? The application layer, right? So there is an acronym. Everyone knows about this one, right? The what was that? Please do not throw saucy pizza away, right? That's the acronym we are even I studied when I was going through all those CCNA things almost a 20 year back. Okay. So the very first layer, the seventh layer is of OSI model is our what application layer, and the fifth or sixth and the seventh, when we are talking in terms of the TCP, these 3 layers will be treated as a application layer. Okay. Fourth layer is TCP/IP, and then the third layer is network, and the second layer and the first layer in TCP/IP is physical layer. And now in even in TCP/IP, they further divided as a data link as well as the physical layer. Okay. So when we talk about the seventh layer, that's the application layer, right? What we are doing there, we are actually communicating with or we are directly interacting with the application. For an example, we gonna do the troubleshooting. Let's suppose your website, your client is saying, or your maybe the consumer is saying that, okay, I am not able to open your website. Website is not loading. Okay, so you're gonna say, can you ping us? Okay, ping is there, but website is not loading. Okay, right? So the troubleshooting steps will be, okay, website means okay, definitely there are protocols which are working at layer 7 and that is not responding all the way. He is able to ping our server. So ping our server means their layer 3 is okay. So this is how you're gonna troubleshoot, this is how you're gonna understand about the layers, right? So okay, uh, let me go through the very quick one. I will share with this document with you guys, so don't worry about this one. So and the presentation layer, sixth layer, we talk about the format. For an example, maybe your client or maybe in your team, let's say you are an infra team and your software developer guys, they are saying, okay, this particular file is not opening. Okay, this particular file is maybe they are saying, okay, I'm able to open the Word file. But I'm not, or even the Word file, this particular thing is not working. The PDF is not. So we are talking about the format. Okay, the compression, encryption and decryption, everything is happening at this layer. Okay, the session layer. there are SIP protocol, session initiation protocol. Basically, we are using in the VoIP technology. Most of you guys have used RDP client. Do you remember, right? You are trying to access any server through the RDP. Okay, so your RDP is not working. Then you have to think about there is a problem at the what rate layer, session layer. There is a problem at the session layer. Okay, the actual work, the network layer, guys, is actual work gonna start from the layer fourth and the downwards, right? Layer fourth is your transport protocol, the transport layer, where the actual transportation of the data packet is happening from point A to point B. For an example, there is a like highway, okay? In the highway, there are a lot of buses, okay? Lot of buses number. There are numbers of buses, okay? They have to carry the passenger from point A to point B, or maybe some consignment. They have to deliver the consignment from a point A to point B location. Okay, so there is a roadways. So roadways is there. There are buses. So buses will be your transport. The numbers in the bus having the number, the port number. What I'm trying to correlate here is we have to think about the port number. Okay, how we gonna make sure that this particular consignment which has been initiated from a point B gonna definitely reach to this particular place. Okay, so we have a certain number to identify that one, that particular consignment number or that particular bus number or whatever. Okay, so that is how we gonna identify through the port number. Okay, so port number basically gonna give you 100% confirmation that the you have initiated a request from the single process, and to it gonna get the reply back on that particular process only. For an example, in your laptop you have a lot of browsers we have nowadays, right? In our days, uh, Internet Explorer was the thing, okay? But now we have tons of browser we have, okay? So let's suppose you are in a browser, in a single tab you have opened a Meta, another tab you have opened X, but when you are trying to do something over the X, their reply or their notification is not coming in the meta tab. The reason behind that one is the transport layer. Okay, that particular process has been assigned with the port number, and that port number gonna be associated with your IP address or the with the packet. We are saying that the WinSock, that's a kind of a concept, WinSock. Okay, so that gonna give you process to process. So always we are saying the transport layer is a process to process delivery or end to end delivery, we are saying. Okay. Then the third layer, the very important layer again came. Okay. That is your network layer. Okay. So the job of network layer is that it gonna give you the network, network IP address identification of your uh, physical devices. Okay, so whether it gonna be delivered in your within your LAN network or it gonna be delivered in the other part of the world, this all thing gonna be decided here. Okay, with the help of IP addressing and the other protocols, all the routing protocols gonna be used here only. You heard about this ICMP, right? What basically ICMP is the protocol we are using every time when we are initiating a ping command. Okay. And the ARP protocol is again very important from the CCNA point of view also. Okay. So I gonna cover this ARP later on. We gonna cover this one with the hands-on lab also. Okay, then the layer 2 came. Okay, the layer 2 basically the all the switches, the smart switches, all the layer 2 switches are working here. Not the all the switches, because when we are saying switches, there are layer 2 and the layer 3 switches also. Okay, so layer 3 switches is basically apart from the switching, it is having a layer 3 capability of routing also. Okay, so all those layer 2 works like MAC addressing, physical addressing. Basically, there are three types of addressing. Okay, port addressing, which gonna work at transport layer. IP addressing, that's a logical addressing, which gonna work at layer 3. And the MAC addressing, we are saying the physical addressing that gonna work at layer 2. So each and every individual in devices must have this MAC address to give the guaranteed delivery to that particular endpoint. Okay, so we are saying endpoint delivery, okay, or node to node delivery, we are saying here. In transport layer, we are saying process to process delivery. Here we are saying node to node delivery. And the layer 3, we are saying is a network to network delivery, we are saying. Okay. And the layer 1 is very much aware of this one, right? All the actual carrying things is happening here, okay? Be it your fiber optics, Ethernet cable, or a Wi-Fi. uh, in my this slide we can see that, okay, the fiber optic is having 100 Gbps. Now it is having more than that one also, okay. Ethernet range is 300-meter ideally, but we are not even going for this 300-meter for this Ethernet cable, right? Okay, and the Wi-Fi range we have 2.4G, 5G, not even the 6 gigahertz already the Wi-Fi range came, okay. So that's a kind of an overview of the network layer and the other layers from the OSI and the TCP. Okay, so let's go for our packet tracer. I'm gonna start with the very basic one. For an example, let's suppose we have one PC here, okay, and another PC at some other part of the world, you can say, or maybe in your, for an example, this is maybe within your company, within your LAN environment, okay, and this particular guy, this is A, he is working alone, or B is also working alone here, okay? But at some given point of time, these two guys in a need of sharing their data. Okay? They need a data from A to B or B to A. What the option they have? They definitely need some kind of a connectivity from here to here, okay, be it a serial connection or a normal Ethernet connection that we're gonna cover in later, okay. But when we are saying one device gonna connect it with the another devices, it will be called P2P. So don't be confused. Most of the time interviewers know they're gonna make you guys a little bit in a tricky situation, put you in the tricky situation that if A is directly connected with B, much like any device is directly connected with the other devices, what kind of a device, what kind of a connection we can say to this one? Whether it is a peer-to-peer, whether it is a point-to-point, they're gonna make you in a like put you in a tricky situation. So always you think about when the two devices is gonna connect it directly, that will be point-to-point, the very first thing. Okay. The second thing, when we think in another terminology like the architecture wise, then we can say whether it is a peer-to-peer or client server. That's a very different thing. Peer-to-peer is at the same time this A or a B gonna act as a server as well as a client, or maybe as a like a either he gonna send on it or receive it, those kind of thing. Huh? So we gonna create this scenario here. That's a very basic scenario you can imagine, okay? And I assume every one of you having the familiarity with this Cisco packet tracer, okay? So what we're gonna do, we're gonna take one PC from here. Sorry, my mouse is giving problem. Okay, another PC from here, and we're gonna connect it, okay? So we're gonna take the automatic link, automatic cable from here to here. So just now what we did, we have a PC here, another PC here, and we did a physical connectivity. So does that mean that it already came into the network? Of course, it came into the that. Does that mean that these both guys gonna communicate with each other? No, because for communication, these two guys, these two particular PC doesn't have their identification, the complete identification. You can argue that, sir, okay, every PC is having a LAN card, so definitely they have a MAC address. But we are not communicating now. We have already understand these models, the model, the OSI and the TCP/IP model. So you can think about that. each and every communication has to go through all those seven layers. So when we are saying about the okay, these two particular PC gonna communicate yes or no, we're gonna say no because till now we have not given them a some kind of a identification for layer three. Basically, that's the IP address, right? So this is how you have to think about now for a layer problem. Okay, so just go here and IP addressing. I'm gonna cover it for a quick in coming days. So let's give it an IP 192.168.1.10. Okay, basically that's a class C IP address. Okay, so what are the class? We're gonna cover it in maybe next day, very quick, no problem. So this is 1.10, and here we're gonna give an IP address of 192.168.1.20, let's suppose. Now it is having these two PCs having their identification for the internet working over the internet. Okay, so if we're gonna initiate a ping request from point A to point B with the help of ICMP protocol, that is the backbone of PC ping request, you can say. So 192.168.1.20, it gonna give us a reply. Okay, so we are getting a reply means we are sending some packet from here, a point A to point B, and it is giving a reply from point B back to point A. So these two PC are able to communicate. That is what the very simple network we can imagine. Okay. So what we have understand till now, that for any communication to take place, there are few major things need to be there. Okay. What are the few major things? Definitely a two people, like a sender and receiver. So here also we have a sender and receiver. Then what else we need? Kind of a communication. So what the kind of a communication? We have a wide communication here. Okay. Third thing. Of course, the message is also required, right? That is what we did here. A ICMP packet we send echo packet we send through the ICMP protocol. And the what other things is required is called a protocol. So protocol, the set of rules, how it gonna govern. Basically, it's in TCP model, and we are using a ICMP protocol to issue a ping request to check whether that we are connected or not. So it gonna give us a reply according to the protocols. Okay, if we have a very different protocol, maybe from here, if we gonna use any server here, and if we able to browse that particular server, definitely there we are using a HTTP or HTTPS protocol. So according to the protocol, it's gonna so these are the four basic building blocks for any communication to be established. A sender and receiver, that the message, definitely the kind of a message you want to transfer from a point A to point B, the communication media, and the protocol as well. Okay, okay. So now I gonna give you guys a scenario. Let's suppose someone coming to you and he is asking you to set up a network for a very medium-sized hospital where there are guys in the admin department who is handling all those admin issues or the management issues of the those hospital. Then there are actual medical staffs who are taking care of the patients. Okay, and then there are uh, so-called IT staff as well as the other supporting staffs. Okay, so you have to design a network for them. Okay, that's the requirement you have. So how you gonna now start thinking about this one? Okay, so first thing you have to think about whether this particular organization need any kind of a communication outside the premises of this hospital, yes or no, very first thing. Okay, because then and there only you gonna decide what are all the devices we have to buy, we have to give it to those guys. Okay, it's not, they are not the one who gonna say okay, I have already a router and the switch, please come and configure for us. Okay, and we gonna start connecting with the cables or a wireless kind of thing. You have to go and sit with them, take a requirement from the client. Okay. If you are in a very initial and a beginning step, these things you don't have to worry about. Your seniors, your project leaders gonna do on your behalf. Okay. But that is what the whole and soul motto is, that how we gonna design our network. Okay. So let's suppose we have a hospital. Okay, so that hospital, for an example, for today scenario is that this hospital is having a few department, and these department need to communicate within their department, not outside their department, for today's scenario. Okay, tomorrow definitely we're gonna go for the inter-department communication. Okay, for that one there is something called a VLAN concept, or virtual LAN concept. So virtual LAN definitely gonna come into the picture. So before virtual LAN come into the picture, what is the LAN actually all about? Okay, so LAN basically, you have a networking device that is called switches. Let's suppose there are switches. Here we have connected two PC, but maybe if we have more than two PCs, maybe 20 PCs utilized by all those department guys. Okay, so how we gonna give them a connection? One way is we're gonna use maybe the hub. That's a very stupid device yesterday we were talking about, right? Hub doesn't have a brain to collect the previous, the port details and the MAC details. So what we're gonna use are here a switch. Okay, with the switch, what we're gonna do? We're gonna connect maybe two to three PC for this scenario. Okay, maybe one PC gonna you know identify themselves as a single department. Okay, so maybe this PC and this particular PC is connected to these switches. So again, I'm asking you guys a question. Once it is, as we said, that switch is very intelligent device. Now, can this particular two PC gonna communicate in this scenario? No, because here also we have not given them any sorts of identification over the network. That is your IP address. Of course, in real life, definitely there will be one server here. Okay, server gonna be connected with this particular switch, and the server is having, or a L3 switches or router is having a DSCP enabled. So these two particular PC gonna take the IP from the DSCP. There is scenario is very clear. But here in this particular scenario, which we have drawn right now here, it need an IP address to communicate. Okay, so our scenario was we have a three department. Okay, so three department option is the industry standard option is we gonna have a very different switch for each and every department. Okay, we are assuming because you don't have to always think about, okay, we gonna give our client a very cheap solution. When you are giving your client a cheap solution, that time you are saving their money. But the very next month or very next year, if there is a kind of a scalability issue will come, how you gonna solve that one? Then again you gonna go to the client and you're gonna say, okay, just give us a budget and we're gonna expand your network. No, then they're gonna say that last year only we have given you guys a budget, right? Those kind of things, bro. So you always have to think about the scalable solution also. Okay, all the way, maybe the organization is very medium size or very small size company. Okay, they will say, okay, we have only 10 or 20 employees. So as you know, normally these days the Cisco switches is coming at like 24 port switches. Okay, so 24 almost like 22 people you can accommodate. Maybe two ports you can use for the maybe the future. Okay, the another switch we're gonna communicate for the trunk port. Okay, so having said that, you always go for the very different switch for each and every department. Depend upon the scenario. Depend upon the, maybe some department have only 5 employee or a 10 employee. So why you gonna waste another 10 or 20 ports for as usually, right? So what you're gonna do? You just, for our scenario, we're gonna take this particular three switches. Okay, and these switches gonna be connected with each other if you can identify here, these lines are a straight line and these lines are dotted line, right? So the reason behind this one is when we are connecting to very similar kind of devices, we are using a crossover cable. And the crossover cable, basically in Cisco packet tracer, you can see it's a dotted. And this straight cable gonna be look like this one. Okay. And then let me take one PC here, one PC here, another PC, and another PC. Okay. Connect these to their respective switches. Okay. So we have now connectivity. Topology is created. Maybe this is the first floor, this is the second floor, this is the third floor, or maybe in a single floor, but they are having a very different blocks for all those departments. Okay. So now let us give them a IP address 1.10. Here we are giving them 1.20, 1.30, one dot 40, 1.50, and 1.60. So now our identification is completed. So does our requirement has been solved till now? Because the requirement was the very problem statement you should always not to forget that one. The statement was each and every we have, let's suppose we have a three department. This is the admin department, this is the medical staffs, and this is the maybe with the all the other supporting staffs department. Okay. So these department inside their department they should communicate, but apart from that they should not communicate with each other. Okay, right now what we did, we give them an IP address. Okay, and we connected each and every one with their respective switches, and all the switches are connected with each other also. Okay, so in this scenario each and every particular PC gonna communicate with each other. Okay, for an example, if you're gonna take it from here to here, you can see here. Wait, this one is successful. Okay, if you're gonna take it from here to another department, this will be also successful. And why it is happening? Because all are connected with the single LAN. Okay, these are the single LAN. But the R requirement was to divide this particular department in a way that they should not communicate with each other. Okay, for today's scenario. For that one, what we have to do, we have to configure a VLAN. That's a virtual LAN. How you gonna configure this one? We gonna configure over this particular switches. Okay. So let's go for the configuration part for the VLAN. This is how you gonna go for the switches command line interface. Okay. And the security right now it's not asking us for any user ID and password. Hey, close the door. 1 second, guys. My babies. Yeah, I was telling you guys that uh, Right now, these switches or any Cisco device is not asking us to or not prompting us to give any password or user authentication just because we have not configured it. But that's a very important thing. We're gonna cover it in these to come. Okay, so go to the pre- executive privilege mode and here config terminal. So right now, if you can see that what are all the ports we have, we can use the command do show run here. So run is basically the whatever the running configuration is there, you can use that command. But let's suppose you are not in the privilege mode, you are in the config global configuration mode, you can use a do so run command. Okay, so these are the basically the configuration. These are the basically the port from 1 to 24 port numbers are there. Okay, and then these are the fast Ethernet port, and then we have gigabit Ethernet port also, that's 01 and 02 these ports. Okay, so there are other command do show ipint brief. So this is gonna have a brief of all the interfaces with us. Okay. Now you can use another command do so VLAN. So this is basically a VLAN information. So right now you can see that one because you can say that sir without VLAN also these particular PCs are communicating, yes or no? You can say that definitely no, because there are something called native VLAN concept. Okay, so native VLAN is by default in Cisco it's a VLAN number one, and by default on all ports they are the member of native VLAN. Okay, so you can see that here we have VLAN number one, the name is default, basically that's a native VLAN. And then by the way, the industrial practice is we never put one VLAN as a native VLAN. We're gonna create very something very different, because for that one we're gonna make a management kind of a port. Okay, so that's a very different kind of scenario. So right now here you can see the from port number 1 to all the way 24, and the gigabit 1 and the gigabit 2 all are the member of this particular VLAN. Okay, that's why these all particular ports are able to communicate with each other. Okay, but if we gonna segregate few ports, okay, then it will not communicate with the other particular port if these guys are segregated with the help of VLAN. Okay, so for that one, what you have to understand is that you have to take care about the port number with which your PC or a device or a in device is connected. For an example, for this particular switch, FA01 and 02, these are the two particular ports these two PC are connected with. Okay, so what you have to do, go for the interface, or before interface, create a VLAN. So you have to create a VLAN database. So VLAN and say 10, and then you have to give them a name. Okay, name, let's suppose name is, for an example, admin. Okay, and then we're gonna create another VLAN 20, and then that is in medical staff VLAN 30, that's a support staff. So okay, so now if you can see, here we have now the three VLAN created: 10, 20, and 30, the admin, medical staff, and the support staffs. And these are in the active states, but port has been not assigned to this particular department. Okay, so this particular only the database we have right now, the VLAN database we have right now. So the what are the way to assign the port to this particular VLAN? By the way, by default, all the switch ports are having a access port, but that's a very industrial kind of practice that even though we know that port 1 to 24 all are access port, but we are going to again define them that so these ports are access ports. Okay, so for that one you have to go for each and every interface. Okay, so let's suppose int fa0 by 1. Okay, so we are in the interface. You can see there config and then if is there. If is like interface. Okay, and then switch port mode access. By the way, as I told you that by default all the ports are in a access mode, but that's a very standard procedure that we are using this command. Okay, then switch port access. Now we have to give them a kind of so. For an example, this particular switch is gonna represent the admin staff. So we're gonna say switch port access VLAN number thing. Okay. Similar for the another port you have to fire the same command. So now if you can see the VLAN information, now you it's visible now that the VLAN here, the 10 name is admin, and the port which were here before 1 and 2 port, it is here now, FA01 and 02. So that is for sure now that this particular two PC is in very different VLAN. Okay, and these are still in VLAN 1. So what you think now? Whether this particular two PC gonna able to reach to these other departments? Because you can say that still those guys that we have not configured or didn't put them in any VLAN. But always don't forget, these all other PCs are also by default a native VLAN member. So the VLAN one. So their VLAN is different. And these two PCs, our VLAN is very different now. So they won't be able to communicate. All the way, these two PC can communicate with each other because these two PC belong to same VLAN. But if we're gonna communicate from here to here, it should not ping. All the way before we were able to ping, right? Before, if you remember here, PC2 to PC4, we have a successful request, but here PC2 to PC4, now it's a fail. Okay. Similarly, you have to configure it here. Okay. So that's an assignment for you guys. Okay. You have to uh, configure this one with the proper labeling. You have to give them here a proper labeling. Okay, that this is an admin department or a medical staffs or a supporting staffs with the proper IP addressing labeling also and the VLAN labeling also, and you have to save that one as a packet, a PKT, and you have to send me back. Okay, we're gonna go through that the evaluation process. Okay, yeah. So till now is I gonna stop it here, and then I gonna open the mic for you guys if you guys have any problem or any question till now. Yeah, guys, go ahead. You guys have any things to say or anything you like to discuss? For everyone, everything is clear. If something is not clear, you can raise your hand or you can talk here.
Why do we use VLAN?
Okay, VLAN. So I'm gonna give you a very different perspective. Is that, for an example, we have or you are in college, right? So in college, why we have a department? Any single guy can do all the thing, right? Because that's not a very rocket science that okay, a teacher cannot uh, do all the assignment or do all the service desk job. They can do it, but we are doing it? No, we are segregating the responsibilities. So when we are dividing our LAN into the VLAN, basically our management is very easy. For an example, HR department are there, their IT department is there, their other supporting financial account department is there. So why the hell HR department should have an access similar to the IT department? Okay, and if not, then how we gonna segregate all those policy at the LAN level? Okay, so this is how the management become very cumbersome if we don't have a VLAN. Okay. Another aspect of this one is there that we didn't discuss till now. That is called a broadcast domain. Okay. Switch support broadcast basically. Okay. So whatever the broadcast packet is there, it gonna forward it to the all the ports apart from the ports which is receiving it. Okay, it gonna forward. But when we are having a, let's suppose, a 20 or 30 or maybe a 300 employee, imagine a 300 employee, and all 300 employee in the LAN network, I'm talking about the LAN network, and in that LAN network, if all are communicating, or let's suppose the ARP packet or the all the broadcast packet is going from each and every PC, okay, so that's not a very good scenario. So we have to segregate the broadcast domain also. So these are the basically two reasons you can say that one. The one is the security part, the management part. Another part, other one is the reducing the broadcast domain. Yeah. Anything else till now? What we have covered? So tomorrow, what we gonna do? We're gonna cover IP addressing little bit because every one of you are already aware of this one. Okay, and then we're gonna cover a subnetting because subnetting is again a very important thing. You have to face it in a real world for sure, subnetting, because there are very few organization where in the router side or in the like edge router side they will give you the full class full address. Okay, so subnetting part is very important again. So we're gonna cover in brief, and then we will go for the inter-VLAN routing. Just now what we did, that we have a very different department, and among these department no one will be able to communicate with each other. Okay, but when will have a inter-VLAN routing, so cross-department talks, cross-department data transfer will be possible there. Okay, so we're gonna cover that one tomorrow. So that's it for today, guys. And I think I made it very clear to you guys yesterday only that we're gonna take this class till next 9 days. Now it's 8 days, 8 more days. Okay, so total 10 days. In 10 days, almost I gonna cover the important, the critical part which you gonna have to face it in any company, uh, medium to small scale. Okay, so yeah, Noel. Yeah, Noel, tell me.
So can you summarize like what we did today? Like just
Okay.
a brief,
You,
just summary.
Okay, you join later. Okay, what we did, we covered the models, OSI and the TCP IP models. The reason why we study till now, or why we have to go through, why we have to understand the models. The reason behind that one, the layered approach. Okay, for infra guys, they have to think in the for the troubleshooting perspective, that is at which layer the problem occur. Okay, this is the problem related to this particular. For an example, if it is a physical cable problem, or let's say NIC NIC card problem, LAN card problem, so definitely it's a layer one issue. But if it is a problem like a website, we are not able to open the website all the way, we are able to ping to that web server. So then that's the problem with the application layer, okay, not the network layer. So till the network layer, we will not think about, okay, there is no problem in router, there is no problem in the root. Otherwise, you imagine, no, if you don't know how to troubleshoot, if you don't know where to start, it will take ages to even solve a single issue. Okay, that's why the layered approach is a very very good things to think about in terms of solving any issue occurred in your network. So we covered the networks, and then how basically we are trying to communicate. Started with the two PC. Okay, why we need a kind of a communication. Let's suppose there was one PC and another PC, and these two PC need to supposed to transfer some data from point A to point B. So for that one, we need a communication, and then we go for a VLAN part. Okay, not the inter VLAN, not the cross VLAN talk communication, only the VLAN. Okay, so VLAN part you already seen it. Anyway, I have recorded this session, so there are few international audience. Those guys were saying that okay, their timing is not matching because they are working for some company. Okay, so they requested us for this recorded video, so I'm gonna share it anyway. Yeah, so that's a wrap up for today's session. Uh, for everyone else, is everything is clear, right? केही छ किनकि हिजो के भयो there were few guys they messaged me personally that sir can you talk in Nepali हैन नेपाली मेरो ठिकै ठाक छ त्यति खराब पनि होइन so because the reason was there were few guys from abroad they don't know Nepali that's why I chose a medium to communicate is English okay that's the only so I tell them that so anyway that's I'm giving this as a I'm not charging for this one so uh, I don't have a foundation to use multiple languages at the same time. So still I didn't know about this guy. Dari Al-Masi. Are you online, Dari?
Yes, yes.
Yeah, yeah. Yeah, Dari. I think we didn't meet. Yesterday you were not joined. Okay.
Yeah,
So can you tell?
yesterday I
Yeah.
joined late after the session finished.
Okay, okay. Can you tell me about yourself, from where you are and what you are doing, your work, whether you are working with some company or in which profile, so that we're gonna work it around the customized solution, like how it will be beneficial for you. Anyway, yeah,
Okay, well, my name is Warren Mashi. I've graduated with electrical engineering bachelor's degree, and I'm working in a networking infrastructure company. So
okay,
I'm planning to get CCNA soon, inshallah, by December. So that's
okay.
why I joined the course.
Okay, okay, no problem, no problem. So if you have any issue you are facing in right now company, you can share with me, not a problem. Uh, we can solve that one. We're gonna give you the kind of a customized solution for you also. Okay. So that's it for today, guys. That's it. That's it from my side. And see you tomorrow at the same time, 6 o'clock sharp, Nepal time. Okay. Bye bye.
Bye, sir.